All right, part 2 of 6.5, we have done all the way through the multiplication and division of quotients, and what we have left is finding the powers of complex numbers and the roots of complex numbers. In other words, we're dealing with De Moivre's theorem, and this is where it gets a little more complicated, so we're going to hopefully take time and explain it clearly. So De Moivre's theorem says let z is some vector, some length, right? R cosine theta plus I sine theta be a complex number in polar form. Remember, this is still polar numbers. If n is a positive integer, then z to the nth power, or z to the nth power, is found by z to the nth equals r cosine theta plus I sine theta to the nth power. Rewritten as r to the nth cosine n theta, so we're multiplying the theta times n, times the power. Remember, power to a power, you multiply, kind of what you're doing here. All right, so write this down, have access to it, and take your time as you go through this. You got 4 examples left. All right, so find this thing to the 5th power, right? So what this is saying is z to the 5th is equal to 2 to the 5th cosine 30 times 5 plus I sine 30 times 5. Yeah, maybe this isn't so complicated, right? Let's see how we do. All right, from here, this is equal to 32 cosine 150 plus I sine 150. Maybe this wasn't so bad. I'd take it back. Finding the root's is going to be a little more complicated, I guess, is probably what I should have said. All right, so now they said, oh, well, maybe it does get complicated here. Find n plus 1 to the 4th power using De Moivre's theorem. Write the answer in rectangular form. Oh, so the question now is, do you want to multiply this out, or do you want to put this in polar form and then convert it back? Good question. My guess is some of you would multiply this out as is. Problem is, what happens if it's to the 10th power or the 20th power? Then you're going to really wish you understood De Moivre's theorem. So here we go. First things first, what is this? This is plotted in 1, 1, so it's right here. We know this is in Q1, right? We need to know R, we need to know theta. So R is equal to the square root of 1 squared plus 1 squared. Square root of 2 is my radius. Theta is equal to the inverse tangent of 1 over 1, right? That looks like that's going to be a 45 degrees, or theta equals pi over 4. Let's deal with radians at this point. Okay, so I know that z is equal to square root of 2 cosine pi over 4 plus I sine pi over 4. And now we want to take this. How did I get yellow? I wanted red. I want to take this to the 4th power. Oh, well, that just means then that we're going to go square root of 2 to the 4th power cosine 4 pi over 4 plus I sine pi over 4 times 4, right? Well, that's just going to be 4, or 2 to the 4th is 16. Square root of 16 is 4, right? Cosine pi plus I sine pi. Okay, but we're not done. I mean, we're part way done. They said leave it in rectangular form. How do I put it back in rectangular form? Well, now I've got to go ahead and put this or find my A and my B values again, right? So we know A is R for cosine pi, and B is equal to 4 sine pi. Cosine of pi is 1. 4 times 1, which is 4. B is going to be 4 times, actually that's going to be negative 1, isn't it? Negative 4. 4 times the sine of pi is 0. So all this to say that my rectangular form is negative 4 comma 0i, or just simply negative 4. And I guess I should write this correctly. This needs to be plus 0i, right? So negative 4. All right, so that one's a little bit more work. And again, take a minute and make sure you understand the process. Each of those steps you've already done in previous sections. You're just applying it now a little bit differently.